Hey folks, welcome back to the channel. So today I'm going to do what I hope is going to be a nice quick project to build this up. And what this is a project that's just been hanging around for almost a year now. Do you ever have projects like that? You know, you start on them in earnest, you get a bunch of the stuff made, you're missing some parts, then you steal some parts out of it for another thing that seems to be more important at the time, and it just seems to get forgotten and lost. And what this is going to be is it's going to be a distributed time base, and it's going to replace this device. This device is a kind of a hand-wired prototype in there, put together with an OCXO that I got off a friend of mine, and it's been wonderful. It's doing the job, but you know, it's just an ugly little thing. I can always give it to somebody or keep it around as a spare or something like that. But I think this is going to be really nice. You know, some of the features of this are this nice little cabinet here, and I got these custom panels made up. These are actually just PC boards, but I've got them made up about 6, 7, well, more than that, 9, 10 months ago. And like I said, they've just been sitting around gathering dust. But now I've got everything, and I'm just going to get this project completed. So I mean, like these cutouts here for the IEC connector, it just snaps right in there, and the switch goes in here. I just got to wire all this up as quickly as I can. Now there's something, I don't see the connectors in this bag of my DNC connectors, but I know they're around somewhere. I have those two to go on the top of the PC board, which has also been hanging around for as long as these panels have. And so I'm just going to quickly go through each stage of the build, put it together, and show you what it looks like in the end. And I have, as you know, if you've been watching my videos, I have a bunch of these cheap repurposed or reclaimed OCXOs. They're really, really good. I did a couple of videos on them. I'll put a link up in there. But they're top notch as far as stability and nice output and all of that are concerned. But just let me get started on this. Now what I'm going to do, the first thing I'm probably going to do is I'm going to mount up the surface mount resistors on this. Then I'll mount up the rest of it. Then I'll wire up the panel. Then I'm going to find a place inside the cabinet for the power supplies. Another one of these little Morrison modules. I love these things. They're perform way better than what they're rated at, and they're very inexpensive. I think something like $7 over on DigiKey. They're awesome. And so that's about it. And I'm hoping this is going to be a nice little addition to my lab here. And that's kind of like what's going to look like. Yeah. So let me get started on that. I'll be back after I get the surface mount components onto this thing and put them through the reflow oven. Okay, so yeah, got these reflowed. I did a pretty nice job on them. A little bit of flux needs to be cleaned up, but other than that, run there really well. I've already probed them out with the multimeter. Everything is fine. Okay, so I'm just going to get to it and mount the rest of the components on this board. And that'll be the next step. I'll come back and show you what that looks like. So here we go. This is kind of what the panel looks like. I did up this LED with a little resistor in it. Probably going to put another piece of heat shrink around it, and then I'm just going to make up a little Molex plug to go on the end of it. But I designed this so that it would be a very nice tight friction fit into the front of the panel. And here's the board all finished off. This little bodge here is just kind of trims the voltage divider down so I can use a 10-turn 500 ohm pot here instead of a 1K ohm, which actually gives me a little bit finer adjustment on the oscillator frequency. And this is just your average 74 AC14. You could put a 7404 in here, it doesn't really matter. I just happen to have these. I don't have the 04s. And these are the connectors I was looking for. I found them in another box. Sometimes when parts come in and I'm not going to use them right away, I just put them in a box of unsorted parts, and I found those in there. So that's the way it looks. I could, a little bit of cleaning of the flux off that. But I'll get to that another time. Today I'm in a kind of a rush. But okay, so the next step now, I guess, would be to either wire up the back panel here, or to figure out where I'm going to put the power supply. So let's do that here. I think I want the power supply kind of to go in over here. So it's got to be far enough away from this corner here to clear those connectors, the IEC connector and the switch. And yeah, that'll be fine. So there's enough room there between the power supply and the back panel to allow for the wiring to come through. And then I just put the output wires on here, and that's good. So yeah, I'm going to mark that there, and then I'll figure out where the holes go. I guess what I'll do next is I'm going to get busy and solder all this up. Okay, so I've got the back panels all wired up, ready to go in. I've got the power supply mounted, and I've also got the 5-volt DC lines are crimped and screwed in, ready to go. So one of these will go up to the LED, one of them will go to the PCB. So okay, next step would be to get that back panel on there and get this all connected up. And before we connect anything up to this, we're going to power it up and do a little bit of a test and adjust the voltage on this. Sometimes these come a little bit maladjusted, but we have the ability. If you look in there, there is a little pot there we can use to adjust it properly. Okay, so let me get this bolted up and we'll be right back. Okay, the power input wiring is all connected up, and the panel I've screwed in with a couple of screws there. I'm going to pop a 1/4 amp fuse into that fuse holder there, and we're going to do some sanity checks. Make sure there's no short circuits anywhere. Put this on. Okay, between here and here, here and here, here and here. Put the switch on. Okay, that's probably just the capacitor and the power supply. And yeah, make sure we're going to the right places here. There's no power on when it's off. Nope, then turn it on. Good. We should have continuity on neutral and on ground. That's exactly what we want to see. Okay, let's measure the voltage coming off the power supply now. We're going to plug it in. I wired this has got a light in it. I wired it up to be a light to show you that's plugged in, because on the back of the panel you'll never see it, and we have a power on LED at the front. So I wired this up as an indication that it's plugged in. I don't know why I did it, but I did it. Okay, so let's plug this in. Yeah, see, that's on regardless whether the switch is on or off. And I just turned it on there, and nothing exploded. Okay, I can see the little LED in the power supply is lit. Let's take one of these here and plug in my front panel LED. Turn it on. That lights. Not very bright, but I don't like them too bright. Bright enough to see. Okay, now let's check the voltage on it. .98. I think we can do a little bit better than that. I need to get non-conductive. I'm going to jam in there. Okay, which one of these is bigger? Just the 1.5 as the other. Okay, let's see if that'll make it in. Yeah. You could struggle through there, I guess. We don't want to touch the case though, because that is grounded. Okay, I'm gonna set a little tiny bit high, so that's about 5.1 volts there. I think that's just perfect. And okay, now I feel confident we can proceed to the next step. So I'm just going to load the front panel on, get all the power connectors hooked up, and we're going to give this a little try. We'll stick it on the oscilloscope and see what happens. Okay, got an oscilloscope hooked up, and I've got this hooked up to the oscilloscope through a 50 ohm load. Let's turn it on, see what happens. Okay, that's not a bad looking signal for a cheap device. A little bit of overshoot here and there, but it doesn't really go above the or below the actual value. It's kind of like a ringing. Looks like we've got like an average voltage of about 1.15 volts peak to peak, which is a little bit less than I had calculated. I had calculated 1.3 volts peak to peak. But that's okay. I mean, all the equipment I'll be running off this, yeah, 1 volt peak to peak or 1.15 volts peak to peak is going to be absolutely fine. And that looks like a fairly decent signal. Like most of them on the external clock input on them, they don't have a 50 ohm termination anyway. So there'll be a lot more voltage there. In fact, let's have a look at that. We'll put it directly into the scope without a 50 ohm load on it, and that's the kind of signal we will get. So we're up around about 2.8 volts mean, and a less square wave. But yeah, this is doing exactly what I needed it to do, and I'll be replacing that device we saw earlier. So that's really all I had to do today. I just wanted to get this up and out of my hair and finished. And sorry I sped through it so much, but I don't have a lot of time today to do this. So I just wanted to just get it done and just kind of bring you guys in on a bit of the process. If you have any questions at all about this, please ask. And when I edit this video, I'm going to put in a little picture of the schematic. It's not much. You could probably guess what it is. So I'm just going to bolt this up the way it is, and you can have a look at the finished product. So here it is, all bolted together. I think it's quite a handsome little package. Looks almost professional, but very, very nice. As far as my projects are concerned, this is pretty nice. Okay, so here's the thing. When I ordered the boards up for this, I had to order 5 of each. You know how the PCB houses are. So I've got my set here, and I gave a couple of them away, and these have been hanging around here for a while. So I will make up 2 complete sets of boards. And if anybody is interested in having them, just leave a comment down at the bottom of this video. I'll leave 2 weeks for you guys to put your names up to decide whether you want a set or not. And so the rules are you have to leave a comment, and you also have to be subscribed. So as long as you've left a comment and you're subscribed, you can win. So anyway, thanks for watching, guys. If you like this, leave a like, subscribe, tell people about the channel. I'd appreciate that. And we'll see you in the next one. Bye-bye now.